సో మనం లాస్ట్ టైం స్టిఫ్నెస్ మ్యాట్రిక్స్ అవి కంటిన్యూ చేద్దాం. ఓకే, ఒక్క నిమిషం. సో దెన్ మ్యూట్ ఆల్. Okay. So see here, u is equal to 1 into x into a1, a2. Then how to find a1 and a2? Okay, now we are going to see how to find a1 and a2. So we are going to take here two nodes, 1 and 2. u1 and u2 is there. So two denotes like this is spring. So this is node 2. The force is acting like this direction. We are assuming tensile. So this is x direction. Okay. So now here I am going to draw some shear force like bending moment diagrams, and this one is coming from here node 1. I'm going to take this one is called node 2. So this you can take u1 and u2. Okay, some of the distance like this, the force is acting like this. So we call this one is called x, and then now here 1, and then here 2. Some amount of slope. So we need to find here a1, a2. So u is equal to a1 plus a2x. How can write means here you can take this the point node 1. We consider this one is called a. There is have any distance? No. So we can take simply 1. The initial condition you can take here 1 like that here. So a1 and plus here it will come a, the area. Okay, area is a2 into x. X means this one. Okay, you can write this like so. This one is you can put 1. This is 2. Okay, now I am going to draw another one. We take first here I assuming 1, and then what happened? 1 denote to another denote. Now here it will come 0. So it will act like this. So the slope we can call here n1. Okay, you can take this one is called n1. And similarly, I'm going to take assuming this one is called 0. And then here it will go in 1. Now I take opposite direction. So this one you can take is called n2. And now how to find n1 and n2 you can see. So this one is called 1. Now ఒకసారి మనం ఇటువైపు 1 తీసుకున్నాం, ఈసారి ఇటువైపు 1 తీసుకున్నాం. Okay, right? So now we see here how to find a1, a2. Then the initial condition is called here the velocity is 0. Then that is equal to u1. Then that is called here a1. See, here is you could put it 0. So that is called here u1. At the same time that is equal to u2. Sorry, a1. And then now we are going to see another one, u, l. So what is L? Now here, this one is L. The distance travel 1 to 2 is called here L, capital L. Then that is equal to the node 2. Okay, this is the node 2. See here, this is node 2. So similarly here we call U2. That is equal to A2L plus U1. You can put it, this is also equation, this is put also equation. For example, I can take this one. In last class, we see there is that equation. Okay, you can take this one is called 1 and then this is called 2. Now we are going to take this is equation number 3. Now this is equation number 4. Okay. Now solve this equation. Solve this equation, we'll get A2. A2 is equal to U2 minus U1 divided by capital L. See. Solve this equation, we'll get this value. So this you can put it equation number 5. Okay. Now see here, this one, okay. And now here we are substituting these equations to this one, equation number 1. We are going to substitute these equations in substitute equation number 1. See, ఇప్పుడు ఈ 1 equation లో మనం substitute చేస్తే ఏమవుతుంది? And then see here, U is equal to U2 minus U1 by L into X, okay, plus U1. Into U1. Yes. Now, then here we see this can put equation number 6. Here I write down 3 and 4. Substitute, not 4, 5. 3 and 5. Substituting equation number 1. Right? So we'll get this answer. And now we are going to in matrix form. In matrix form, we express U is equal to 1 minus X by L into X by L, then U1, U2. This is the matrix formation. And then here, this you can put, this is the slope. So we can denote this is N1, and this one you can take is called N2. So now here we see the N1 is equal to 1 minus X by L, and N2 is equal to X by L. You can write down like this, the slope of value. Here we see, you can write down this one, U is equal to simply N1, N2, U1, U2, like this. Okay, so since N1 is equal to 1 minus X by L, and N2 is equal to X by L, like that. Okay, this is all called shape function because the Ni is expressed the shape of assumed displacement function with respect of coordination with the x-axis. Coordination of with the x-axis. Now we are going to take this is tensile force. I am assuming here tensile force, the opposite force also acting. What happened? ఇప్పుడు tensile force నేను ఈ పక్క కూడా అప్లై చేస్తే ఏమవుతుంది? Okay, now we are going to see here. Tensile force. The direction is X, and then here this is K is called deflect stiffness of spring, and this is denotes 1, 2. Now here too, some of the distance is moved. So this one is called here U1, and some of the distance is moved in this direction. That is called take 2. And now this is original length L. You can assume just assumption. This is original length. Now I tensile this spring. Once this direction and this direction. Then it will change the denote to u is the distance is called u1 and this distance is called u2. Okay. So now here once similar way. This process is similar. The first step we are going to take 1 in one side to take n1 is equal to 1. Okay. Here is n1 is equal to 1, n2 is equal to 0. And then here n2 is equal to 0 and n1 is equal to 1. Sorry, n1 is equal to 0, n2 is equal to 1. See, this is 2, 1, and this is 1. This is coming from 1. Similarly, we are going to exchange this thing also. Okay, exchange this. And we will get that the thing is here coming to the point n1 plus total n2 is equal to 1. Notes of the value. Okay, the shape of function over the domain of the string element. Okay, any axial coordinate along with bar. And now here the interpolation function may be different from the actual function except at the endpoints of nodes. This endpoints of nodes. Where the interruption function and actual function, the interruption function and this actual function, okay, both are same. This interruption function means this actual function, the both are in same. So that is called equal to specified node values. So now here we take another thing, how to find shear, how to find strain. Now define the strain or displacement and stress or strain. Now we are going to take this relationship. We studied in MOS. Okay. We studied in MOS this. Define the strain, displacement and stress or strain relationships. So then here we are going to take the tensile force T. Here I am going to take tensile force T. Produces a total elongation, deformation, that is called here delta, okay, of the spring. So this one is called tensile force. Tensile force is called T and delta is called here deformation. We take deformation, delta, okay. The typical total elongation of the spring, okay, that one is here. We are going to take this one. The typical setup is here. You can assuming this is the tensile force we are applying here, right? Now, see, hence U1. Here you see this U1 is acting negative. Is acting negative. The thing here. Example, this is U1. Okay. And then see here, this code is U2. We are going to take x direction, the both sides. That is called a tensile. Okay. Now the U1 is acting minus opposite direction. That's called here minus U1. And this is going for with the direction of x-axis in positive direction. I'm going to take U2. That's the simple thing. Okay. So whereas U2 is positive value. So the deformation of the spring. Now here, the deformation of the spring delta is equal to U capital L, that is the length, minus U is coming from 0, that is the initial position, that is equal to u2 minus u1. How we can write? See, this one here you can take the assumption as 0, this is L, and then now here it will come, this is U into L, and this one coming from U into 0, assuming, then here this is called U1, and this one is called U2. Now I can write down here U2 minus U1, minus means already I said, this is in negative direction. The force is acting in negative direction. Okay, so then you can take this is equation number 1. So now in this equation we observe the total deformation is difference of the nodal displacement in the x direction. మనం ఇక్కడ అబ్జర్వ్ చేసి చూస్తే మనకు అర్థమైంది ఏంటంటే the nodal displacement with x direction లో మనకి total గా ఇదైపోయింది. So then for a spring element we can relate the force in the spring directly to the deformation. Therefore, the strain displacement relationship is not necessary in here. Why? Because we can relate the force in the spring directly to the deformation. ఇక్కడ డైరెక్ట్ గా మనకి deformation జరుగుతుంది. There is no any other additional force. The spring is directly deformation. So that's why we are not to take strain displacement relationship in here. So the stress strain relationship can be expressed in terms, we know very well that the T tensile stress is equal to K into delta. K into delta. Then now T is equal to K, yes is, but delta is equal to U2 minus U1. You just substitute this value in here. Okay. So this is the equation. We can find force. We can find force, tensile force, with help of this relation. Okay. And now we are going to see here another one. Derive the element stiffness matrix and equations. Derive the element stiffness matrix and equations. Then here we know derive the spring element stiffness matrix by the sign conversion for nodal forces and equilibrium. Nodal forces and equilibrium. Okay. And now see here, that's the thing here we see in a previous, see here this one. This is the nodal functions. Okay, we see that functions mainly f value. We see here the functions, the stiffness matrix K. Then here the function. We already discussed this thing. At the same time here also, derivation of the stiffness matrix. This is here we see the functions. Okay, then similar we are going to see here also the same functions. Okay, I'm going to derive these equations for f1x is equal to minus t, f2x is equal to t. Why here we put minus? That the tensile force is acting in opposite direction at one point. First node, the tensile force is acting in forward direction at node 2. Then here the function of this f1 is equal to minus t. The function of node 2 is equal to positive t. Then here we write down t is equal to minus f1x. Then this one is coming from here. The k f1x is equal to, you can write down k into u2 minus u1. u2 minus u1. So because of here, K into D. Clear? F is equal to K into D. Then K, we are going to take K as usually. And then the D place here, we are going to take the force, tensile force. We are applying tensile force. We are going to take T. Now already we find T here, K into U2 minus U1. Similarly, I am going to write down this function F. The similar way here, F2x, that is equal to K into U2 minus U1. Okay. So now we write down here, F1x is equal to K into U2 minus U1. And then F2x is equal to K into U2 minus U1. The both are in same. Here the both are in same. Then we are going to put here, this is equation number 1. Okay. So now in this equation, see very clear. In this equation, now I am going to express single matrix equation. Now expressing equation 1 in a single matrix equation. That is F1x, F2x. That is equal to K minus K, then here square, K. And the function of here U1 and U2. This is the matrix function. Okay, you can write that expression in here like this. Now here the K. See this K, the relationship holds for the spring along the x-axis from our basic deformation of the stiffness matrix. And application, here we write down K minus K. So here as the stiffness matrix for a linear spring element, here K is called the local stiffness. This one is called the local stiffness matrix of the element. We observe from equation here, this one, this you can put equation number 2. So you can observe this equation number 2, that K is the symmetry. See, K is a symmetry. That's the opposite. Okay, that's the thing here is Kij is equal to Kji. It's called a square matrix. It's called a square matrix. So that means the number of rows equals the number of columns. Okay, the number of rows equals the number of columns. Okay, right? This is the thing. We are going to find the stiffness matrix, element of stiffness matrix. Okay. And next we are going to see here, assemble the element equations of obtain the global equation and introduce boundary conditions. How to introduce boundary conditions? We are going to discuss about this element equations and introduce boundary conditions in next class. Okay. Now we are going to see some doubts. So here 18 numbers. Okay, now I am going to unmute yourselves. ఓకే, మీరు ఇప్పుడు మ్యూట్ చేసుకోండి. Sir, unmute చేసుకోండి. Now you can unmute yourselves and ask any doubts. Now, how many members today? 20. Okay, చెప్పండి. Good morning, Viranji. ప్రమీల అటెండెన్స్ తీసుకున్నావా? హలో,
సార్ నన్ను తీసుకోమంటారు లేదే?
తీసుకోబా.
తీసుకున్నా సార్.
తీసుకున్నారా? ఓకే మా, ఓకే 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 రైట్. ఇక ఎనీ డౌట్స్? ఇప్పుడు మీ ఎగ్జామ్స్ ఇప్పుడు వచ్చేసరికి ఏంటంటే కంపల్సరిగా మీరు రావాలి అని చెప్తున్నారు డిస్క్రిప్టివ్కి. ఓకే, సో 12th నుంచి మీకు ఎగ్జామ్స్ జరుగుతాయి. సో 12th నుంచి మీరు కాలేజీకి వచ్చేసి అందరూ డిస్క్రిప్టివ్ ఆన్లైన్ కంప్లీట్ చేయాలి. ఓకేనా? నౌ హియర్ మనం దాని గురించి తర్వాత డిస్కస్ చేద్దాం. ముందు డౌట్స్ ఏమైనా ఉంటే చెప్పండి. ఒక 5 minutes. 5 minutes తర్వాత మీ ఎగ్జామ్స్ గురించి డిస్కస్ చేద్దాం. Okay, now stop the recording.